had you do, since this was in factored form, the whole little x minus 2, x minus 6 idea, what we had just kind of talked about in the previous few days is the idea that whatever solves this, so that when we set this equal to a 0, that those solutions there are your x-intercepts. So if I ask you to solve this set equal to 0, the solution to this one is x equals 2. So that would have been one of our x-intercepts. And we would have put a dot on 2. Did we do that? Is that what we did? Okay. And then the second one, the solution is x equals 6. So that then is your other x-intercept. And we would have put a dot there. So I think that's probably what we would have started out with for sure. Because if you're in factored form, that's what you can get from factored form very quickly. Okay. All right. Then from there, all the other stuff, it's hard to get the rest of this stuff from factored form. What factored form really gives us is our solutions and our x-intercepts. But in terms of our vertex, axis of symmetry, your y-intercepts, max, mins, domain, and range, not a lot of easy ways to decipher that from this mode. So the next version that we want to put this in, I don't know if we did this yet. You probably want to put this in the standard form next. Did we do that yet? We did. Okay.
I think we did this one together, actually.
Did we get it all done, though? Okay. I think we got it started. So, yeah. So some of this is going to be a little bit of a review. So that standard form basically means I need to multiply all of that out. So I'll do it over here. So when we did that, we would have talked about how we're just going to drop that 2 down, and then you're going to distribute. So x times x gives us an x squared. The x times a negative 6 is a negative 6x. Negative 2 times x is a negative 2x, and the negative 2, negative 6, positive 12. We would then combine our like terms inside of those parentheses. So the negative 6 and the negative 2, we would have had a negative 8 plus our 12. And then the last thing now, we kind of deal with that 2 at the end. You're just going to distribute the 2. So 2 times x squared minus a 16x, and then plus a 24. That then is our standard form. Okay, and you're telling me we did that part of it already? Is that correct? All right. What standard form is nice? Yeah, sure. What standard form is nice for is finding our y-intercepts. Okay, so this was the one little new thing that we did on Friday, or no, Monday. I'm confused. Is finding our y-intercepts. And what we talked about for your y-intercept, and I had you write it in, whenever you cross the y-axis, we said that the x-coordinate will always be a 0. So if we go to this standard form right here, just do that. Let your x be a 0 in that equation. So if I want to now figure out what's my y value, if this x is a 0, that whole thing is a 0. 16 times 0 is a 0. And then all I would be left with is 24. So the y-intercept here would have been 24. If we can graph it, I would want you to graph it. If you look at our graph, 24 is not going to fit on this unless we start changing kind of the scale and what each tick mark means. We're not going to do that. But what ultimately happens, if you can recognize this as we get to the test and we do these here in a minute, if this is in standard form, doesn't our y-intercept, if we went back to number 1 as well, didn't the y-intercept just end up being this constant hanging out at the end? All right, that's not a coincidence. That will always happen. That ends up being our y-intercept. So if you're in standard form, you can get the y-intercept by just looking at that. All right. Okay, did we do vertex form in this one? Okay, so that's where we got to. All right, good, because that's probably the hardest of these. Now, this is what we spent a ton of time on. This is what we've already quizzed on. We had some modest success there. Now it's just kind of a matter of remembering it all. So now what we're going to do is put this into vertex form. So vertex form is doing the whole completing of the square. So what we did is we took this 2x squared. Hold on, that's right there. But we took these first 2 terms. And remember how we figured out what our common factor was between those? And in this case, it's going to be that 2. That's what we pulled out. And if I do that, I'm left with an x squared minus an 8x. But we didn't take it out from that 24. We left the 24 alone. So if I distribute this, I still get 2x squared, and then the 2 and the -8 give me a -16, and then I still got that 24 hanging out in the back. So same exact stuff, just written a little bit differently. All right, real quick, this we did review on Monday. If you want to draw your square, go ahead. But if I have an x squared in the upper left-hand corner, and I have a -8 split evenly between the top right and lower left, what's the bottom right-hand corner of our square? That would make that a perfect square. Write that down real quick. Make sure we got that part done. On the test, there's 1 or 2 questions of just that, like just what makes a perfect square. So that's something we should be able to do, just even not in the context of all of this. All right, what makes that a perfect square? What would that give us, Armando?
16.
Good. So that's a 16. And notice how now that's new to our problem. That's not part of the original problem. So if I just add a 16, then I need to go to this back end and I would need to subtract away what I just added. Where this gets a little sneaky, and this was probably the most missed thing on that quiz. We are not just subtracting a 16 right here. All right, the reason we are not, can somebody tell me why we're not just subtracting a 16 right there? Remember? Jada? Good. So when we put this 2 out in front, it actually means that 2 is being distributed to 16. So we have 2 16s. When we actually did these with our little squares, we drew 2 of them. And we would have had a 16 in both bottom right-hand corners. So 2 16s is actually a 32. So we would want to subtract away a 32 from that. Okay. Thank you, Jada. All right, now we can put this into vertex form finally. So, and then that's going to help us graph it, answer the rest of these questions. Vertex form is probably our nicest one. It gives us the most information. So if I had a -8 total, that meant I had 4 and 4. So I would have had an x minus a 4 times an x minus a 4. 24 minus 32 is a -8. All the rest of this we should now be able to complete. So write your vertex down. That I do know we all have a good handle on. So write the vertex down, plot the vertex, draw in your graph. So once we write it down, once you plot it, we should be able to draw in the rest of that graph. All right. Let's see here. Joe's back. Omar, what's our vertex for that guy? Good. +4, -8. So we write that down on the line. We also then graph it. And it should fit nicely. Like if this doesn't fit and give us a parabola that opens upwards, we know we screwed up. So 1, 2, 3, 4. Notice how that's right in the middle. Go down to 1, 2, 3, 4, 5, 6, 7, 8. Graph it. That's what our graph looks like. That should now allow us to answer the 4 remaining blanks. Okay, by just looking at that graph. All right, so let's see if we remember all of this now, since we have a test in 48 hours on all of this. Julia. Ready, Julia? What's our axis symmetry, Julia? Good. So far, so good. The axis symmetry is always a vertical line. X equals a number. It's got to be the x coordinate of your vertex. So x equals a 4. All right. And then CHAM, if this is a parabola, it looks like this. Do we have a minimum or a maximum? All right. Is there a high point or a low point on this graph?
A low.
So a low point means we've got a minimum. Okay. We don't have a max because this thing just goes up forever. So our arrows just tell us we're going to continue to go up. So there is a minimum. And then what you would be expected to do is tell us what the minimum is. So if we look at this dot right here, what is it? Negative what? Good. It's the -8. That's the y coordinate of our vertex. That's the lowest point on this graph. The domain are all the x values that you're going to hit. Again, your initial thought with any domain and range question is to ask yourself, do we, for domain in particular, for left and right, do we go left and right forever on that graph? Yeah, and there's no interruptions, there's no breaks, there's no little holes, some of the stuff you would have dealt with in Math 1. So that's -∞ to infinity. Same thing with your range. Range goes up and down, so you're just going to ask yourself, does this go down and up forever? And again, if it is, then that's your answer. Does it go down forever? No. So that's when we got to kind of rethink a little bit. We got to look at our graph, most likely. Does it go up forever? Yeah, so that part's fine. This you kind of already have done. All right. Wouldn't our lowest y value that we would have hit, wouldn't that also be the minimum that we would have stated right here? So -8 is the smallest y value, and then we go up forever. Okay. That's number 2. So now keep in mind kind of what we just did. You were given factored form and expected to give the other 2 forms, standard form, vertex form, and then answer all these questions. The one we did on Monday, you were given standard form, expected to give me the other 2 forms and answer all these questions. So the only one we have yet to do, which is why we're going to skip number 3 because that's factored form, is go to number 4 because 4 is now vertex form. And if I give you vertex form, you should be able to give me the other 2 forms and still answer all of these questions. Now, vertex form is the nicest form. So what I'm going to have you do right away in vertex form, answer this question. We should be able to do this. You should be able to do your axis of symmetry. We're going to sketch a quick little graph here in a minute, but that should be the 2 that we can do right away with our vertex form. So state the vertex, state the axis of symmetry. All right. And Nora, what is our vertex, Nora? Good. 1, -9. And then Ben, what is our axis of symmetry? Sort of. Don't just put 1. So always write it as a vertical line. So just put the x equal to 1. All right. But in terms of the number, yeah, it's a 1, but just write it as a vertical line, x equals 1. So we can get that right away. All right. We can also plot that on our graph. So go to 1, -9. 2, 3. Plot that point. And then from there, now we need the other stuff. All right. Standard form, again, is just you simplifying this. So we want to simplify this as much as we can. So let me do this over here. So I'm going to rewrite this as h of x equals, and then this x minus a 1 squared. I'm going to write x minus a 1 times x minus a 1. That's the whole x minus 1 getting squared. We'll just write it as 2 separate ones. But we've still got the little -9 hanging out in the back. Then there's some work involved here. We now got to distribute. You got to combine your like terms. You got to go through that process. So that's what we're going to do next. So the x times the x gives us that x squared. The x times a -1 is the -1x. The -1 times x is a -1x. And then the -1 times a -1 is a +1. And then we still got the little -9 just kind of waiting to do anything. All right, once this is simplified, that's our standard form. All right, just multiplying everything out, combining our like terms, that's standard form. So you're going to get your x squared. Then a -1x and a -1x put together is a -2x. +1 and a -9 is a -8. Once we've multiplied, combine our like terms, what that results in is standard form. All right. So whether it's in factored form or vertex form, to get to standard form, you're just multiplying everything out. What I want you to do now, tell me what the y-intercept is. See if you understood. We did it, introduced it on Monday. We just did one a minute ago. We should now be able to get our y-intercept from that standard form. All right, and it doesn't take any work whatsoever. Anybody know what that is? What is our y-intercept, Armando? got to be the -8. Okay. Again, think x equals 0. Where'd you get the -8 from, Armando? Good. So if we go up to the equation that we just created, the standard form equation, if we let the x be a 0 right here, so that's what we do when we find a y-intercept, this would go away, this would go away, and the only thing you were left with is the -8. So as long as you are in standard form, that's your y-intercept. Okay? So for any problem, you don't necessarily need to change yours. So if I go to the bottom of this paper and I give you like x squared plus 6x plus 7, and I ask you what your y-intercept is, it's 7. That's it. If I give you, and that's only if you're standard form now. So just make sure we're understanding this is only if we're standard form. This is standard form. Your y-intercept is that -10 hanging out in the back. Okay? You don't have to give it any thought as long as it's standard form. Now, that actually gives us a point to plot. So go to your y-axis. We know we cross y equals a -8 right here. Guaranteed. Doesn't that also mean if we have an axis of symmetry cut right down the middle, if this is our line that cuts this right down the middle, if this is a point on our graph, doesn't one unit to the right of that line also have to have a point on it? So it actually now gives us a couple of points to start to graph this. Okay. All right. And then finally, factored form. So this is what we've now been doing the most recently. So factored form is now taking this standard form equation right here and factoring it. So factor this guy for me. So how would this factor? All right, anybody got that? Again, this is hopefully what's most fresh in our minds, what we've been doing for the last 2 weeks. So if I ask you to factor this, what would we multiply together that would have created this little trinomial right here? Okay. All right, anybody got that? Other than Armando? Julia? Good. X minus 4 and x plus 2. If we multiply those together, it gives us the -8. If we add a -4 and 2 together, it gives us that -2. So that is your factored form. All right. What that now allows us to fill in the rest of these. So once I have factored form, now go down to your x-intercepts. We use factored form to get your x-intercepts. Factored form gives us the x-intercepts because now you're going to let your y be the 0. And then again, this is what we've been doing quite a bit recently. Whatever solves this equation or this little expression here, which would be a +4, that's one of your x-intercepts. At the same time, we're going to plot that point. So go to the x-axis at 1, 2, 3, 4 on the x-axis. You're going to put a point. If you notice right now, the right-hand side of this parabola is forming nicely. Pretty good indication that we've done so far everything correctly. If I ask you to solve this factor to see what makes this one a 0, that should be x equals a -2. We can then plot that. And if you look how this one lines up with these guys, everything should look pretty good. Okay, so then we go ahead, sketch that in. That's our parabola. And then once we have the graph, that should allow us to hopefully be able to do these. So now do the max min, tell me what it is, domain, and then the range. And that I would propose the easiest way is just look at your graph. All right, Sarah, do we have a max or a min, Sarah? Good. There's a low point on that graph. Basically, just asking, is there a low point or a high point? It's obviously the lowest point right here. And then what y value is that lowest point? Good, -9. We can get that just from the y coordinate of the vertex. You can actually look at the vertex and see what this lowest y value would have been, what tick mark you're at. That's a -9. If I ask for your domain, Maddie, what do you think, Maddie? Good. That goes left and right forever. To be honest, don't mess that up. Everyone that we've done so far for the domain is -infinity to infinity. That's not going to change between now and Friday. So that should be an easy one. Okay, all of these have gone left and right forever. The range is the one that's a little trickier. Lily, what do you got, Lily? Good. -9 is the smallest y value, and then we go up forever. So that's our range. Okay. If you can do these, you really kind of understand everything that we spent the last month doing in this module. Okay. We're stopping there. I wouldn't worry about the bottom of the paper on that. You can put a big X through all of that. None of that would be relevant to the type of question you're going to see on Friday on your test. But certainly the 3 that we've done on this, you really want to be able to do this. You're going to have to do this on Friday, where I give you a form and you got to work your way through all that stuff. Okay. That is somewhat similar to the one that you also have in front of you now. So, where at? Go to the review that I gave you. Screw this up. And then we'll just see where we're at. All right, first few things we have quizzed on, and it went reasonably well, where I want you to graph each parabola. And then you're going to identify the x-intercept, y-intercept, x-intercept, all that stuff, vertex. And then you're going to write the equation of the axis of symmetry. All right, so if I give you number 1, first identify sort of what form is this in. Is this standard form? Is this vertex form? Or is this in factored form? So when we look at this we should hopefully recognize as vertex form. So write your vertex. To work. This I can confidently say we're all pretty good with. Kira, what is the vertex for number 1?
3, -2.
You have it backwards.
Oh, -3.
Good. So the one in the parentheses is the one we want the opposite sign. The one on the back will keep that sign. So -3, +2. Plot that point. So -3, and then a +2. Eventually, we're going to graph this. While it's not asking you, first time we've dealt with this in a little while, notice how there's a negative number in front of this. So this should be opening downwards, correct? That's what we talked about that number meaning. So when we do this, it should open downwards. All right, so we have the vertex. We want to figure out what is our y-intercept, what is our x-intercepts, and then write the equation of the axis of symmetry. So actually, the axis of symmetry we can do right now. So do that for me real quick. And then we've got 2 of the 4 things that we want. Oh, it's down there. Okay, good. So -3, 2. All right, then our axis of symmetry, Jake, would be what?
X equals -3.
Good. X equals a -3. All right, so we've got 2 of the 4 things. Then x-intercepts, y-intercepts. Don't draw this because we're going to draw this in nicely, but we know this is a parabola that opens downward, so it's going to look something like this. So notice how we have to cross the x-axis 2 times, if that's the case. So that's why we have 2 blank lines. All right, but we need to find out what they are. We're not just going to guess. All right, so to figure out our x-intercepts, that's when we yeah, that's where we're going to actually pull your calculators too. Let's make sure we remember all that. It's been a while. You have a test. We're going to let you use your calculators. It will not be cheating to know how to use your calculators. And we did this back in the day. It's been a while. But let's say I just gave you this and I don't explicitly tell you to put it into standard form or factored form. And I'm not in this case. So because of that, if we have a calculator in our hand, we should be able to answer these two things right here without having to do all the work for it. I'm going to test you on the work, like right here, number 3, I'm going to make you do the work. But if we have a calculator in our hands, we should be able to answer these two questions by graphing it. So go ahead and graph this on your calculator. I got to pull mine up, and it's a bit of a process. So go ahead and graph that on your calculator. Make sure you can do that. Come on. And in reality, we could get the vertex from this as well. All right, let me do a regular window here. Okay, we all looking at that? You have your calculator? If you do, I can look at that, pretty quickly identify what my x-intercepts are. So if you look at your calculator, can't we tell pretty quickly where that crosses the x-axis? Okay, because of that, you can then write those down pretty quickly. It crosses the x-axis right here at a -2, and it crosses the x-axis right here at a -4. So if we had gone through all the work, multiplied it out, factor it, all that good stuff, -2, -4 are your x-intercepts. So go back, put that down. So this would be x equals a -2 and x equals a -4. All right. Now, the y-intercept's a little trickier just because it looks like we got to be a little bit bigger. So it's up to you how you want to do this. So here's how we can kind of see this a little bit. Go to where it says window right here. So here's my mouse where it says window. Notice how we want to go lower. So don't we need more negative y values? If we want to go lower on this, I need to go bigger negative y values. So in my window, go to your window. Notice where it says y minimum. That's the smallest y value that we can see on our graph. We just need to go lower. So all I'm going to do is move on down here. And if I want to look lower on my graph, I'm going to change this to a -20 because now I should be able to see all the way down past the -20. So that now when I graph it, doesn't it now appear as if it's crossing our y-axis? Now we count our tick marks and we can identify where that crosses. So you can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right, 15 is our y-intercept. Okay, and I'll show you one other way we can do that also. All right, so that's our y-intercept. All right, last way to do this. Then I'll have you maybe try that next one. That's how we'll kind of finish on our calculator. Next thing, go to where it says right here. See where it says table? So upper right-hand corner, very upper right-hand corner in blue, it's table. It's blue. That means we want to hit the blue key here. Hit second table. Oh, let me change mine because yours will not look like that. All right, if I now go to my table, remember what we talked about in terms of these values. When y is 0, isn't that when we get our x-intercepts? So we also could have just gone to our table. Notice how a y value of 0 is a -4 and a y value of 0 is a -2. Isn't that what we put our x-intercepts to be? So we also could have done that. Our y-intercept is when your x is a 0. So go to your x column right here. And notice how the x value of 0 is right. Actually, we miscounted. See, this is actually nice because I did not count the right tick marks. At x equals 0, our y-intercept is actually a -16 versus the -15 when I tried to count those tick marks. All right, so that's actually a nice little way to check those. Go back and make this a -16. Come on, you. Pen doesn't want to work. There we go. All right. Then we can graph this. The x-intercepts are -2, -4. Go ahead, drop that guy down, and we get that parabola that opens downwards. Okay. All right, so now this one, I want the vertex, but if all I'm asking you is that, and I don't tell you to explicitly put it into vertex form, it is okay for you to graph this on your calculator and kind of cheat and just look at the graph. So that's what I would propose you're going to do. You could certainly multiply all this out, put it into vertex form. There's some work involved. I'm going to make you do that at some point. We'll do them here momentarily. But if you just use your calculator, so do that right now, graph it and see if you can just look at your calculator and find your vertex. And then we don't have to go through all of that work. Yeah. What's that? Oh, yeah. Go ahead. There's no homework. We're just going to finish this up tomorrow. Okay. All right. Is that what everybody's graph looks like if you graphed it? Can't we just look at that and say what our vertex is at this point? Doesn't it have an x coordinate of -1, -2, -3? So -3 for x. And then don't we just go down to a -1? So if you can just graph it on the calculator, then very quickly, we could have said that this vertex was a -3, -1. And then it seems like we're remembering the axis of symmetry. So far, no one's had an issue with that. We can right away say x is a -3. That's your axis of symmetry. If I want the x-intercepts, let's go back to my graph. Doesn't it appear these also cross at a -2 and a -4 on the x-axis? And then that, hey, we've got time. Have a seat. We got 2 minutes. When we go to our y-axis, we are crossing the y-axis at 1, 2, 3, 4, 5, 6, 7, 8. So our y-intercept is the y value of 8. You could also have gotten that from your table again. If I go to my table, just find your zeros in the table. Here's where y is 0, -2, -4. All right, so this point right here and this point there, and then go where x is 0. And when x is 0, notice how you get the y value of 8. Okay, and we know that's our y-intercepts. All right. So if you have the calculator in your hands on Friday, totally acceptable to just kind of do this. We're going to test you on rewriting everything here, so you're still going to have to do that. So don't necessarily think you're cheating if the calculator would make things easier. Okay. Which means you probably want one for Friday to make some of these a lot easier than what they would be without. Okay. Bring this tomorrow. We're going to finish this off. And then again, we'll cross our fingers where we're at on Friday when we finally test on all of this. Okay.